All right, we're going to be looking at now solving multi-step inequalities. I'll give an introduction and then we'll solve a couple examples. And some tips, some things to remember. First off, remember the onion. That's a rule I gave in a prior video that helps you decide what step to do first when you're working towards isolating for a variable. And I'll just do a quick reminder here where if we have 3p plus 8 equals 25, do you deal with the 8 or the 3 first? We figure that out by building an onion, circling the pieces that are closest to the variable, following order of operations, and then we gradually peel away that onion. And so in this case, we would see the 8 is exposed first. We would subtract 8 from both sides. Then we would deal with the 3, and eventually we would have p isolated for. Okay, so that's what I mean by building the onion, or remembering the onion. Next thing is to remember the rule to flip inequalities, and as a reminder, that's when you multiply or divide by a negative, you need to flip the direction of the inequality symbol. That is a super common step to forget to do, and the way I check that at the end is by plugging in an extreme answer and to see if the inequality sign is written in the correct direction. So let's do this first one. 4p minus 6 is less than 26. We can add 6 to both sides. And 4p now is less than 32. And it looks like we have one more step. Divide both sides by 4. And we have p is less than 8. So p has to be smaller than 8. And as a way of plugging in an extreme value, another option you could do is plug in a 0 if 0 fits. And here 0 is less than 8. So that's an easy thing to plug in. So is 4 times 0 minus 6 equals negative 6. Is that less than 26? Yeah, it is. It checks out. Okay, so we did it correctly. This next one involves using the distributive property. I'm going to actually try to do it in 3 different ways. One without using the distributive property, one with the distributive property, and then in a third way, I'm going to try to do it without ever dividing by that negative 3, okay? Because I want to try to see if we can get a solution without needing to multiply or divide by a negative. So let's see if we can do that guy. So first, let's just do it without the distributive property, where we will divide both sides by negative 3, and we get an x minus 4, and we flip the inequality because we divided by a negative, so that's less than or equal to a negative 2. So we divided both sides by negative 3 there. We can add 4 to both sides, and we get an x is less than or equal to positive 2. Okay, that's my final solution. One quick check just to, well, I guess actually here, let's just see if we get the same solution for each of the 3 methods, and we'll call that our check here. So for our second method, I'm going to distribute the negative 3. Negative 3x plus 12 is greater than or equal to 6. We can subtract 12 from both sides, and we get a negative 3x is greater than 6. And, excuse me, I think I did that wrong. 6 minus 12 is a negative 6. So negative 3x is greater than negative 6. And as our final step here, we will divide both sides by a negative 3, which means we need to flip the direction of the sign. So x is less than a positive 2. And what have I missed here? I missed my equal sign. So way back up here and here and here, I forgot to make those greater than or equal to, so I'll add those in. And then when we flipped it, it turned into a less than or equal to. So it looks like we did it correct, but I'm glad we compared with our first answer to remember to use that equal sign in there. And then as our last method, what I want to do here is actually use this distributed form. We have a negative 3x plus 12 is greater than or equal to 6. And my goal is to try to solve for x without needing to multiply or divide by a negative, just to confirm that we really did need to flip that sign. So here I'm actually going to add 3x to both sides, and at the same time, all in one step, I'm going to subtract 6 from both sides. And let's see what we get here. So these guys cancel, and these guys cancel over here. So on the left side, we end up with a 12 minus 6, which is 6. We don't flip the sign because we never multiplied or divided by a negative. And we have a 3x on the right. Okay, so we can divide both sides by 3. These 3's cancel. We have an x remaining. Sign stays the same. 2 is greater than or equal to x. And then typically with inequalities, we want to have our variable on the left. It makes a little more intuitive sense. So we're going to flip this whole statement around, including the inequality sign. If 2 has to be bigger than or equal to x, x has to be smaller than or equal to 2. So we did end up flipping the inequality sign, but hopefully you can see that we did it in just a final step to make the answer make a little more intuitive sense. We're going to look at one example where we have variables on both sides here. And as always, when we did this with equations, we thought ahead a little bit about what side we want the variables to end up on. Where are there more x's? That might be where we want the x's to end up. First, though, I'm going to distribute and simplify. 3x. I'm going to combine like terms also in this step. So 3 times 5 is 15 plus 1 is 16 is less than or equal to 4 minus x. So I want my x's to end up on the left because I have more of them there to begin with. So let's add an x to both sides. And these guys cancel. We're left with just a 4 on the right. 4x plus 16 is less than or equal to 4. I'm seeing I don't have any negatives, so it looks like I won't have to remember to flip any signs here. I'm going to divide both sides by, or subtract 16 from both sides, excuse me. We have a 4x is less than or equal to 4 minus 16 is a negative 12. And dividing by 4, we end up with an x is less than or equal to negative 3. I actually want to do a check here, and I will do that by plugging in the boundary value, the negative 3, and let's make sure it just just barely works. So I'll rewrite my equation, and we're curious if that's less than or equal to 4 minus a negative 3. So 3 times 2 plus 1, is that less than or equal to 7? And it is. It's exactly equal to 7. So that makes me feel pretty confident I did the problem correctly. I want to show you a couple curiosities. Sometimes you will get some infinite solutions, and sometimes you'll get some no solutions as well. So let's run through both of these, and that'll be the last problem for this video here. So I want to distribute on the right-hand side. Negative 15 minus 5x is greater than or equal to negative 5x minus 15. I think you can see we might be getting an infinite solutions here. It looks like we're about to get the same thing on both sides, but let's make sure we are correct in that thinking. I'm going to add 5x to both sides. And I have a negative 15. Those guys cancel. Is greater than or equal to negative 15. So we're going to have an infinite solutions here. No matter what we plug in for x, we will get a valid true statement. Okay, and so x could be anything. X could be any real number. All right, for this last one for today's video, let's distribute here. We have a 4 plus 3x is less than 3x minus 6. Okay, so we can subtract some things from both sides. We can subtract 3x from both sides here to simplify things down a little bit. And Our 3x's cancel. We have 4 is less than negative 6. So another contradiction and impossibility. We saw that a little while ago with equations when we solve some of equations that had no solutions. 4 is certainly not less than negative 6. So there are no solutions to this guy. And let me actually write down in the first of these two examples, our final answer is x can be any real number. Okay, so a couple just kind of unique problems that sometimes you'll come across that you want to be aware of. And that's a good place to stop right there.